Hi folks, my name is Jorge Palma and I'm a program manager for Azure Kubernetes Service. Today, we'll be talking a little bit about how you can modernize your applications leveraging Azure container technologies and programs. Please ask any questions throughout the presentation on the chat window and our experts can help answer them. As part of our agenda, we will discuss Azure's strategic pillars for Kubernetes on Azure. We'll see how AKS and Azure are working to make your Kubernetes journey and experience as easy as it can be and effectively make you successful, whether you're just getting started or preparing your service production launch. I'm really happy to show and demo to you some of the things we've been working on and that we're announcing here today. Finally, we'll review which tools and programs you can leverage to be successful wherever you might be in your Kubernetes journey. Let's start by discussing the pillars of Kubernetes on Azure. AKS's mission has always evolved with the needs of our users, and today, as it provides an enterprise-grade platform for all your applications, we want to ensure that we keep making the best possible experience for you by providing built-in, personalized best practices for your clusters that you can easily apply to achieve operational excellence, cost savings, or better availability, for example. On the security front, AKS provides the easy knobs you need to secure all the layers of your solution, from the container to the pod to the node, all the way to the cluster, but also the Azure Platform Network and Compute resources. Moreover, Azure provides end-to-end solutions like Azure Defender and Azure Security Center that traverse across these and help you secure several layers of the stack at the distance of a click or a command. As usual, you can replace all these first-party solutions with your favorite third-party or open-source solutions. Now, with a scalable, resilient, extensible, and portable platform such as AKS, a key aspect is ensuring operational efficiency at day 1, day 2, and day 30 of operations. AKS provides you with the simplified and automated experiences like auto-upgrade, auto-scale, and auto-repair to make your life easier, while at the same time giving you the flexibility and control with things like maintenance window, custom node configuration, or AKS run command. Finally, it's normal that your number of environments becomes large or grows over time. So it's key that you keep consistency of management and configuration and are able to easily govern anything from tens to thousands of clusters, be those AKS clusters or any other Kubernetes clusters in any environment. As such, AKS is more than just a managed Kubernetes service. Together with Azure and Microsoft's tools and ecosystem, it's a full enterprise platform to host your applications and deliver value to your business. You can leverage VS Code and GitHub for your container-driven development processes, Azure Container Registry as your image repository, and Azure Monitor for Containers as your end-to-end monitoring and logging solution. Similarly, on top, you can see that we can use Azure AD as your central authentication directory, Azure Policy, Azure Security Center, and Azure Key Vault to secure your clusters and workloads, and Azure Advisor to have recommended best practices for your clusters. Finally, and at the bottom, thanks to Azure Arc, you can have this AKS experience consistently on clusters outside of Azure anywhere. But a cornerstone of these end-to-end solutions is our open source strategy and commitment, where all of these solutions are built first and foremost in the open and governed in the open. They are built to work with any Kubernetes cluster anywhere, and then have a first-class integration with Azure to simplify and deliver great experiences. This can be seen in projects like Dapper, a development runtime system to simplify cloud-native application development, or our Azure Policy integration mentioned before. This integration is based on OPA Gatekeeper, which was developed originally by Microsoft to be an admission engine that guarantees and enforces policies within your cluster, and was donated to the Cloud Native Compute Foundation, where it has been thriving and is the basis of many current solutions in the market. Not stopping there, we wanted to make the experience both very easy and scalable, so we integrated Gatekeeper with Azure Policy, giving users an easy way to enable the Gatekeeper functionality and have a large amount of pre-existing policies that can apply to all their clusters with a single click. All of this is reflected on the trust our customers and users place in us, with AKS powering some of the most important systems in the world and truly being the world's distributed platform of choice. Now let's look into some of the ways AKS is making your Kubernetes experience and journey easier. Over the last year, AKS has launched a number of features and resources to enable you to use the appropriate best practices for your cluster and workloads. Aside from the previously mentioned Azure Advisor and Azure Security Center recommendations, the baseline architecture for AKS includes all the necessary recommendations for your cluster based on an organizational business needs. It also comes with a reference implementation to help you deploy and get started. The AKS Diagnostics and AKS Periscope give you the necessary tools to easily troubleshoot and investigate issues with your clusters. The AKS and Kubernetes VS Code extensions, as well as Bridge for Kubernetes, provide you with insights and visibility into your clusters straight from your IDE and allow you to have a simple development and debugging flow for your container applications. Finally, all of these can be found on the extensive best practice documentation for AKS that is at your disposal. Now let's look at some of the new and upcoming features that we've been working on to simplify your experience and kick it off with a demo.
As we get started with our journey, the first thing that we will need is an AKS cluster. Though AKS has several knobs and switches, the Azure portal makes the create of a standard AKS cluster quite easy by providing you with the default values for most settings. However, for most specific scenarios, you may need to spend some time to understand the right values for the various settings and options that AKS gives you. To help you with this, we will be launching cluster configuration presets in the AKS Create experience. With it, you'll not only be able to learn the right configuration suited for your scenario, but also apply it to your cluster with a single click. In this case, we will choose the hardened access configuration, and you can see how the applicable settings have changed. We now have a different SKU selected, we have 2 recommended node pools, as well as Azure Monitor and Azure Policy enabled by default. You can add any final customizations you want, and then go ahead and create your cluster.
Now that we have our cluster created, one of the new things the AKS portal is bringing to you is a new node and node pool experience. Let's take a look.
We will use our already created cluster to explore the new node and node pool views. The new experience will allow you to see the Kubernetes node object properties like labels or taints side by side with the AKS properties like node pool mode or node image version, and complement it with the ISVM properties like the OS disk size or tags. This will give you a seamless experience that merges the Kubernetes and Azure API capabilities. If we navigate into one of these nodes, we can see its node conditions, the metrics, or even explore its YAML output, where we can find relevant information, for example, like the attached volumes. Alongside it, there are also updates to the AKS node pool view creation and update flow that allow you to easily update configurations and have more options available when creating a new node pool.
Now that we saw how easy it can be to get started with a cluster and interact with it, let's see how we can migrate an existing Java app to AKS through Azure Migrate.
Let's see how Azure Migrate app containerization tool can help you containerize ASP.NET and Java applications that were running on servers and migrate them to AKS. For this demo, we have an open source Java web application called AirSonic that I have running on an Ubuntu machine on my lab. AirSonic is a media streaming application that runs on Apache Tomcat and uses a MySQL database for the data tier. I've already migrated the data tier to an Azure database for MySQL instance using the Azure Database Migration Service. Now, we'll be attempting to containerize and then deploy the AirSonic web application using the app containerization tool. Let's jump into my server real quick and see the running JVM processes. I also want to show you the /var/airsonic directory on the local file system that the app uses to cache its media content. Since this directory is used for dynamic content that the app serves, ideally, we'd want to move this directory to a persistent volume when we containerize the app. So, let's start by downloading and installing the Azure Migrate App Containerization tool on any machine that has a network connectivity to my app server, and then go to the tool's web-based configuration interface. Here, I select the type of app to be containerized. In this case, will be Java on Tomcat. Then I connect the tool to my Azure account by logging in and selecting my Azure subscription. And then I have the tool connect to the app server by specifying the connection details and discovering the applications hosted on the server. When this step completes, the discovered apps are listed, and I can select the ones that I want to containerize. In this case, I'm going to select our AirSonic app. I specify a name and a label for my container image build, and I review the application configurations that were discovered. Here, I can parameterize the discovered app configs by selecting them, and as you can see in this case, the tool has detected the presence of a database connection string in the app config files and is offering us the option to parameterize these and make them a container deployment time setting. So let me do that and parameterize the database connection details for the app. I can review the various app files and directories that will be layered onto my base image. This would typically include the directories containing the application binaries and config files. I have the option of how to specify additional directories from the machine to be included in the container image, as well as directories that should be moved into a persistent volume, such as the /var/airsonic directory that we saw earlier. The tool will take care of creating the persistent volumes and copying the data from the app server to them, and will also help me create the persistent volume claim to mount the volume to my pod when I deploy it. So now we're ready to build our container image. So we select the Azure Container Registry for the image and review the suggested Docker file that the tool has automatically generated based on the discovery information. We can make further customizations to the Docker file as needed using the inline editor, and then build the container image through the app. The image building is done through ACR tasks, and we'll push the image to the container registry specified. With the build complete, we're now ready to deploy the app to AKS. So we select the AKS cluster to deploy the app to, and we'll select this Kitozo AKS cluster that we have already created with our presets. We can specify any configurations in the deployment, such as the number of replicas to deploy, the type of service to create for connectivity to the app, and for any application configs that we parameterized previously. I'll also specify values that these parameterized configs should take in the current deployment. In this case, I'll specify new values for the database connection string details that I had parameterized previously, and I decided to point them to the migrated MySQL database on Azure. The tool will then accordingly create the Kubernetes manifests to deploy to AKS, which we can then review and make any edits as necessary. We can even deploy the app to AKS from right here on this UI. We see that the app is now being deployed to AKS and is now deployed to AKS. So let's verify that, and actually let's try to connect to the containerized app that is now running on AKS, getting the IP. And there you have it. Using the app containerization tool, we were able to take a non-containerized Java web app that was running in a server, follow a templatized guided process that helped me containerize the app and replatform it without having to spend significant time and effort to rewrite or refactor the application. All the artifacts generated by this tool can be downloaded and integrated into a new or existing CI/CD pipeline and used for subsequent day 2 operations as well.
Fantastic. So we easily got started with a cluster and migrated our app to AKS. But what about going to production? The AKS baseline reference architecture and implementation could help us with that. But what if your workload is under regulatory compliance requirements? How can you achieve that compliance with AKS? To answer this question, we're announcing the new reference architecture and reference implementation for AKS, focusing on regulated workloads. This implementation builds directly upon the original baseline cluster reference implementation and adds to it additional implementation points that are more commonly seen in regulated environments. You can easily access it from Azure Architecture Center or our Cloud Adoption Framework. Let's see what this guidance looks like and demonstrate with a cluster and workload deployed following it.
This is the page for the cluster reference implementation for regulated workloads. In our implementation, we're using several AKS core configurations and Azure components. But as mentioned before, you can really leverage the open source ecosystem in full to either replace some of these pieces or complement them. This implementation creates a private cluster integrated with Azure AD for centralized authentication directly. It uses Azure CNI as network plugin and enables the Azure Monitor for Containers, Azure AD Pod Identity, Azure Policy, and Open Service Mesh add-ons for monitoring, logging, and security. Within the cluster, we have deployed an Nginx Ingress controller, a web frontend, and 3 microservices A, B, and C. All communication is secured by TLS, but not just from the client to the cluster, but also within the cluster, pod-to-pod traffic is secured with MTLS via OSM. We have a zero trust networking model leveraging both native network policies as well as a non-permissive layer 7 network restrictions thanks to OSM. To deploy this solution or similar skeleton for your workloads, you can follow the deployment steps provided below and the supplied ARM templates that will get you set up in no time. Now let's look into a cluster deployed following these instructions. Now let's take a look at the cluster that our reference implementation has deployed. Now, because this cluster is actually a private cluster, we're not going to be able to access it directly from the internet. So instead, we're going to be using a jump box that is deployed into a virtual network and subnet that is peer to our cluster subnet. But because these jump boxes also don't have any public IP, what we'll do is we're going to leverage Azure Bastion in order to access them directly from our browser. I already have used Azure Bastion and I'm already logged into our jump box here. And because these jump boxes are actually based on the images that our reference implementation provides, it already has a few tools installed that we can use. And so we can just very quickly use Azure CLI to merge our kubeconfig. And we already have as well the kubectl binary, so we can start accessing the cluster. Now, because this cluster is actually an AAD enabled cluster, we're going to have to essentially log in for the first time if we want to access any resource. So we're going to do just that. And once the login is actually successful, and the user is authenticated and has the right permissions to access resources, we should see a successful output. We see our two node pools, system node pool and our user node pool, to have segregation between system components and applications working well here as in this cluster, in this implementation. And we can take a look at what's running inside the cluster, and we will see that essentially we have all the infrastructure we talked about, from Open Service Mesh to Azure Policy to our application and our microservices as well. If we access our application, bicycle.contoso.com, you'll see right away our zero trust networking in place, where essentially only one flow of traffic is allowed from the web front end to the microservice A to microservice B and microservice C. And this is the only flow allowed. If any other thing is attempted, it will be immediately rejected by our network policies. So if microservice C tries to access microservice A directly, it won't be able. So you'll see only one call is possible for each one of these components. All other calls are rejected. At the same time, if we try to do something mischievous and do some mischievous requests to our workload, this will be immediately detected and blocked by our web application firewall, in this case, application gateway, and that will prevent any malicious attempts to access our workload. Coming back to the cluster, if we want to test something like deploying a privileged container and see what kind of policy did our reference implementation deployed, we'll see that it has a number of built-in policies already deployed, including policies that block privileged containers, as I was attempting to deploy here. So as we see with this, we had a very easy way to have a fully secure skeleton that we can use for our production needs.
That integration is achieved via the CSI Secret Store open source project, and today we're happy to announce the public preview of the Managed CSI Secret Store add-on that simplifies the installation and lifecycle management of this solution in a fully supported manner. Let's check our cluster once more to see it in action.
In our cluster, as we saw before, we have an ingress controller, and in order to terminate TLS, we want our Nginx ingress controller to have access to a key vault secret and certificate. Now, as you can see, I already went on and enabled CSI Secret Store add-on in this cluster, and we have a pre-created key vault via our reference implementation. So what we need in order to achieve the next step is a secret provider class that we can reference from our ingress controller deployment. The class looks like this and has all the info we need about our key vault. But how can our ingress controller pod, and only it, have permissions to access this key vault and these respective secrets? That's where pod identities come in. We have as well created an Azure identity that we have given access to our key vault, and we are binding this identity to our Nginx controller pod. Let's take a look how the Nginx ingress controller deployment is making use of both a CSI Secret Store volume to access the respective certificate that we can see right here, and have a unique identity binded to it with the same name that we just saw before, right here. Now, we can take a peek at the key vault that was previously created, and we'll see that both the certificate referenced by our ingress controller is right here, as well as the necessary permissions to access the secret by the ingress controller identity are specified right here.
So now, all our secrets are coming from Key Vault, and our production cluster is shaping up to security and compliance needs. But what if we, for example, have compliance requirements like FedRAMP? Another announcement in this space we're quite excited about is the public preview of FIPS compliant nodes. The Federal Information Processing Standard, or FIPS, specifies the security requirements for cryptographic modules that protect sensitive information. It is a standard for the United States and Canadian governments, for example, and applicable to systems that are required to be, for example, FedRAMP compliant. This new node image option contains the important cryptographic modules that meet the federal compliance and have FIPS mode enabled. This should help you achieve compliance with relevant standards or assist in your path to obtaining an authorization to operate a federal information system. Let's see how easy to deploy FIPS compliant nodes in our existing cluster is.
So our existing cluster already had 2 node pools, if you remember. So we're just going to add a new node pool with a FIPS-specific image and running in FIPS-enabled mode. This new node pool is going to have 1 node only and is going to be added additionally to the already existing 2 node pools. So it has been created successfully, and we can confirm it has a node image version that includes FIPS, but we can now shift into our jump box and confirm with kubectl that we actually see that node there created 2 minutes ago, and that it in fact has a different kernel version than the other images, and it has a FIPS-specific kernel version.
Now that we have hardened our cluster, how can we ensure that we don't increase the operational cost of multiple clusters at scale? One of the key things we need to worry about is authentication and authorization at scale. So to simplify that challenge, we're happy to announce the general availability of Azure RBAC for Kubernetes authorization. Let's take a look how it can simplify your operations at scale.
So to see the Azure RBAC integration in action, we actually have 2 clusters, RBAC1 and RBAC2, that we were going to try and give the same set of permissions. So we're still going to start with RBAC1, and we're going to try and access it for the first time. It's a fresh new cluster, AD integrated, so we're going to have to authenticate first, and we're going to try and get pods from all namespaces. Unfortunately, this user has no access given to it. Usually we'd have to bootstrap a cluster role binding or add a AAD group for the cluster admins. But with Azure RBAC integration, you can actually just jump into the cluster IAM blade, add a role assignment, and search for a special set of roles, which are the Kubernetes RBAC roles. These are built-in roles that are giving authorization permissions to the Kubernetes API, and you can even create your own built custom roles on top of these built-in roles with your specific permissions. So in this case, I'm going to give the RBAC reader to my user. So essentially, I'm going to try and have read access at the cluster scope. And when I try this again to get pods, now I'm going to be able to see it. But if you notice, I only have read permissions. So if I try to do some writes, like deploy an application, that's not allowed. But let's assume that I actually want to give this user some granular permissions. I can still do that with Azure RBAC. So you can go ahead and get your cluster ID, and now through the CLI instead of the portal, we can give this user the Azure RBAC admin role, but now not to the cluster scope, but instead to a specific namespace, in this case, default. So now this user has read access to the full cluster, but it has admin access to the default namespace. So now he's able to actually deploy this application, but he's not able to create any new namespaces because that would be an action outside of the default namespace. Now, how can we do this at scale? So very simple, because this is basically just Azure RBAC, you can actually apply it at a resource group or even subscription level. So in this case, we're going to go to the build 21 resource group where both our RBAC1 and RBAC2 clusters are, and we're going to give the same exact RBAC reader role that we gave to RBAC1, we're going to apply it at the resource group. And once that's done, we're actually going to fetch the kubeconfig for our for a brand new RBAC2 cluster. And once that's done, we're going to try and issue that same command again. Once more, we're going to have to log in for the first time. And once we're authenticated, unlike on the first occasion, this time we already have permissions granted at the resource group level, and so this command actually succeeds. But if we try something else, like create namespace, that will not be possible.
Now that we've done all of this, how can we ensure if the cluster is compliant and secure and make sure that nothing was overlooked? Together with the Center for Internet Security, we're happy to announce the AKS-specific CIS benchmark, a benchmark tailor-made for AKS to ensure your environments are secure and compliant. You can access it and use it today. Now, modernizing with containers is a journey. As you address larger, more sophisticated forms of cloud adoption, your journey to cloud becomes more complex. To help you get started, here are some programs and resources. We've consolidated guidance, learning content, and reference architectures for modernizing with containers in the Cloud Adoption Framework. This framework combines technical and non-technical considerations required to prepare for Kubernetes and container integration into your cloud strategy. You can get the help you need to simplify your journey to the cloud. Wherever you are in your cloud journey, the Azure Migration Program can help you accelerate your progress. The Azure Migration Program offers proactive guidance and the right mix of expert help at every stage of your migration journey to ensure you can migrate infrastructure, databases, application workloads with confidence, as we did before. All customers can access resources and tools such as free migration tools, step-by-step technical guidance, training, and help finding a migration partner. And speaking of partners, Microsoft recently launched the Advanced Specialization Program to help our customers identify partners with specific expertise and whose capabilities and technical practices have been vetted through a rigorous third-party audit process. The Kubernetes on Azure Advanced Specialization validates partner expertise in deploying, managing production workloads using containers and managing hosted Kubernetes environments in Azure. To earn an advanced specialization, partners undergo a review of their deployment processes and architecture to make sure they're adopting Microsoft and industry best practices around security, networking, availability, governance, as well as alignment to well-architected design. The partners you see here have earned the Kubernetes on Azure Advanced Specialization and have demonstrated that they have both the skills and experience to deliver best-in-class cloud-native capabilities to customers with Azure. To see the full list and learn more about these partners, visit azure.microsoft.com/partners. Thank you for tuning in today. To read more about some of the announcements shared today and more, head over to the blog at aka.ms/mad/blog. And make sure you tune in to the Ask the Experts session where you can reach out with your questions and engage with our subject matter experts. Thank you.